So we're going to look at some more compound trigonometric applications. Compound trig applications just mean that you have more than one triangle that you're going to be looking at, which means you'll have to look at breaking them up into multiple right angle triangles and work on each one individually to get to your final destination for the problem. There is a couple things I want to talk about in terms of terminology, in terms of their northeast and southwest orientations. So on this little grid, north, east, southwest, we should know that, but if you can't remember, there's many acronyms to help you remember that. We were going to look at 4 different measurements and how they actually relate on this grid. So when it says n 50 degrees east, it means that from the north we go 50 degrees towards the east side. When it says S20 west or S20W, from the south we're going to go 20 degrees towards the west direction. When it says south 60 east, same idea. From the south we are going to go towards the east 60 degrees. And for north 10 west, that means from the north we are going to go 10 degrees towards the west side. So we're going to look at an example that most of these are word problems in this section. There are some that have multiple triangles that you have to solve one step and then into another step, into another step. But this one we're going to look at how to use a word problem with this notation so we can actually draw our triangles. Now this one says that you have a surveyor that's laying a road due east from A. So to make this easy on ourselves, let's put A right in the middle. There's our point A. This person is due east at point B at our lake. She's going to change her direction to north 33 degrees east. So based on where she is physically, we make a little grid. From the north, she's going to go 33 degrees towards the east. And it tells us that she's going to go for 2,400 meters. So let's make that distance here. Okay. And that is point C. She then turns south 42 east. So same idea. We're going to make a little grid so we can see which way we're going. From the south, we are going to go 42 degrees, so approximately there. To reach point D, which is on the east-west line through A. So she has to go all this distance all the way down here to this point, D. Now they want to know how long is this distance. So that's what we do not know. That's what we want to figure out. So if we formalize this a little bit better, this is the diagram we're working with. But we can see that we've got 2 right angle triangles that are joined. We want to find this side here. We know this is 42 degrees. We know this is 2,400 meters. And we know this angle here is 33 degrees. So the remaining angle will go here. Or you can say this angle up here is also 33 degrees because they're alternate interior angles of parallel lines. So we can fill in this angle here is 90 minus your 33, which will give you 57 degrees. We also know this one is also 33 degrees because, like I said, when you have 2 parallel lines, you have alternate interior angles. This angle here is the same as this angle here. And now we have our 2 right angle triangles to work with. Now we want to solve for x on this side here. And let's label this. This is our B, C, D. So we want CD, and we're going to have to work with triangle, let's call this point E, BCE first to solve something that is shared between the two triangles, which is the side here, CE. So, first step, for triangle BCE, we want to solve for a shared side, which in this case is CE. So we need to solve for that side. Now, in order to solve for that side, let's use our 57 degrees. We have an opposite and a hypotenuse. So, we know we're going to have to use sine of 57 degrees is going to equal CE over 2400. Multiply both sides, and then we can figure out what CE is. Now I'm going to leave it like this. I don't want to round this value. I could plug in my calculator and get an approximate value, but I definitely do not want to round this value. We're going to use that shared side to help us solve for x. So the second step, we're going to be looking at triangle CED, and we need to solve for side CD. We have an angle that's given, it's 42 degrees, so based on that angle, we want to solve for the hypotenuse, and we have an equation here for the adjacent side. So, adjacent and hypotenuse is going to give us a cosine. Cosine of 42 degrees is going to equal, and in this case here, the adjacent side is this full value, a non-rounded value. So if you have it in your calculator already plugged in, that's great. Just do not round this value. We want to isolate for CD, so I'm going to times both sides by CD and then divide by cos of 42. So we're going to get CD is going to equal this value here that you have not rounded from your previous expression over cos of 42 degrees. Now by plugging this entire expression into my calculator, I will then get CD is going to equal approximately 2,708.5 meters, which is what we want to know.